Hello and welcome to another LeetCode video. Today we're going to be doing the problem of the day for July 17th, add two numbers to. It's a good linked list problem, helps you, use linked lists. Also, you have to know how adding actually works, like in normal addition, which is kind of important. Okay, so you're given two non-empty linked lists representing two non-negative integers. The most significant digit comes first, and each of their nodes contains a single digit. Add the two numbers and return the sum. You may assume the two numbers do not contain any leading zero except for the number 0 itself. And so we have this first example where we have 7, 2, 4, 3, and we have 5, 6, 4. Okay, and so what we're actually doing here is we need to be adding like down this way, and the least significant bit's going to be over here, so we're going to need to be adding from the right. So we're going to have a 7 here, we're going to have a 0, we're going to carry a 1 here, then we're going to have a 7 plus 1, so that's going to be an 8, and then we're going to have a 7 here. And so that's going to be our answers for this. And finally, they're going to look like this. Okay, so that's going to be our linked list for the first one. And similarly for the second one, I'm not going to draw out the whole linked list, I'm just going to draw out the actual numbers. So we have 2, 4, 3, and we have 5, 6, 4. So we're going to be adding from the right again, and so we're going to have a 7, a 0, carry the 1, and an 8. So it's going to be 8, 0, 7. And then finally for the third example, it's 0 plus 0. So obviously for 0 plus 0, it's going to be a 0. Okay. So how do we do this, and how do we make it easier on ourselves to do this? Well, the thing is, if we start with like these last elements, right? So let's just go back to the first example. Let's use another color maybe. So let's use green. Okay. So like let's say we have this essentially 7, 2, 4, 3, and 5, 6, 4. So we can get to like the very last element to add them, but then how do we traverse backwards, right? Like we can add these two elements, but how do we traverse to these two elements? So what can we do here to make life easier for ourselves essentially? And wouldn't it be nice if our lists were reversed? Okay, so let's take a look what that would look like, right? If our lists were reversed. So instead of this, we're gonna have the same 7 to, actually we're just gonna keep it like this, but we're gonna delete these. So we're going to delete these, and we're going to put them in reverse, right? So let's say our lists now are this way. Well, now this is a lot more straightforward, right? Like we can compare two elements, then we can just go to the next two, go to the next two, because we can use the next pointer. So step number 1, what we are actually going to do is we are going to reverse the lists. And so we're going to make a helper function to reverse the list. That's pretty straightforward, just how to reverse a linked list, that type of thing. And it's pretty straightforward. You just use a previous and a next pointer or a current pointer, and you just, swap these arrows. I'll go over that in my code. I guess we can go over it really quick. Maybe some people aren't familiar with how to reverse a linked list. So let's do that really quick. So let's say we have a 5, 6, 4. And I'll just show you how to reverse it really quick. So we're going to have a head. So let's just say we're going to have a head, and it's going to be like this, okay? And then we're going to have a previous pointer. Previous pointer is going to be null. And at every step, what we're going to do is we're going to make a temporary variable that's going to be the next of the head. So let's just call that here. So we're going to make a temporary variable here, and then we're going to say let's make the head point to previous. So we're going to make the head point to null. Then we're going to delete this thing. And then finally, what we're going to do is we're going to make the previous equal to where the old head used to be, and we're going to move the head up over here. So now the head is actually going to be, let's delete that as well. And let's actually make a new head. So now our head is going to be over here, our previous is over here, and then our arrow is pointing there, and then we can finally delete this previous. Okay. So our head's going to be there, and we just keep repeating this. So once again, our previous is over here, our head is over here. We're going to do the same thing. So we're going to make a temp node over here now. At the head.next, we're going to delete this. So now this is like this. Then once again, we are going to make the head point to the previous. We're going to make the previous come over here, right? So previous is going to come over here, delete this, and then the head is going to go to where the temp used to be. So now the head is going to be over here, and this temp is deleted. And now finally one more time, right? So we're going to have a temp again, except now our temp is out of bounds. So we're going to make the head point to the previous. So that's going to look like this. And that'll be there. Then we're going to move the previous to where the head used to be. We're going to make the head out of bounds. And then finally, so this previous is gone. Now finally our head is out of bounds, so we're done. And then we just return the previous, so you can see how this 564 looks like this list over here. But yeah, that's how you're going to do that. Pretty straightforward for that part. So we're actually going to get rid of all this now. So we did reverse the list. Now what are we doing? Now that I showed you how to do that, now what are we doing? Well, now we can just add one number at a time, right? So what we're actually going to do is we're going to be adding one number at a time. We're going to first make my dummy node, which is I recommend you to do a lot because that'll give you the new head of the list. So let's say we are going to make a dummy node, just over here. And now what we're going to do is we're going to be adding. And now we have to figure out pretty much how to add correctly, right? So when we add, what we need to do is we need to have one more variable in an add. The way an add works is you have a carry in and carry out bit. And so so this is going to be number 2 add. So we're going to have a carry in and carry out bit, but actually we're going to use one bit to do that. We're going to use a carry. So we're going to make our carry equal to 0. Then every time we add, we are going to add these numbers. So like we're going to do 3 plus 4 here. That's going to be 7, and we're going to add the carry. So it's going to be, let's write it over here. So it's going to be L1 plus L2 plus the carry value. And now if one of these doesn't exist, then we're just going to take the other one, right? So like in this case, we would just take this value only because this one doesn't exist. Okay. So that's what we're going to do. We're going to do L1 plus L2 plus the carry value. So the carry value starts off at 0, so let's do this. So it's going to be 3 plus 4 plus the carry value, which is 0. So that's going to be 7. And now that we get the 7, our actual value we need to be putting in, so our value, let's call it, is going to be whatever this add is. So add mod 10. Okay, because like let's say we get 17. If you think about what would you do if you have a 17, you would put in a 7 and then you would carry the 1, right? So our value is the add mod 10, and then our new carry is the add divide by 10, and it's going to be an integer divide. So if we have like 17, this carry would now be a 1. But anyway, so let's do this. So this is a 7. We don't, 7 mod 10 is 7, and then this is like this. We're going to make this here. And then we're also going to have a current node that's going to be, it's going to start here and it's going to move every time. So we start here, we're going to move over here, and now we need to add these. And what's our carry? So our carry is the add divide by 10. So 7 divided by 10 is 0, so that's going to stay 0. Okay? Now let's just say this is L1. This was where the node was. This was where the node was. Now they're going to actually move over here now, right? Because we just used those values. So L2 is going to be here, L1 is going to be here, and now we have our current is going to be over here. It's going to move, right? We make a new node, we move, and we move these two. Okay, now we need to add one more time. So when we add, our total is 10, but our value is total mod 10, which is 0, right? Oops. 0. Okay. And now what's our carry? Our carry is 10 divided by 10, which is 1. So now our new carry is 1. We're going to put in a 0. Our current is going to move over here. And now our L1 is going to move over here. And our L2 is going to move over here. So we have an L1. We have an L2. Okay. Now we need to add these two. So we have a 7. But remember, it's L1 plus L2 plus carry. And our carry was 1. So it's actually going to be an 8. And what's our value? So our value is the add mod 10, so 8 mod 10 is 8, right? And then what's our carry? Our carry is add divided by 10. So 8 divided by 10 is 0, so now it's going to be back to a 0. Okay. And now our current is over here. And now these values move, so this one becomes none, and this one becomes 7. Okay? And so now we have 2 more values, so this is none, so we can just say, like, if it's none, let's just give it a 0, and let's take the other value. So this is a 7. So we're going to have a 7. We don't have a carry bit. So it's going to go over here. Our current is going to come over here. And now our carry is 0. So now we finally have a linked list where our current is over here. But from the picture, you could see that this is like reversed, right? So if you look over here, we need to reverse this list one more time. So how do we do that? Well, we actually want this node over here, right? So we need our list to look like 7, and then next 8, next 0, next 7. So what we need to do is we're going to move our carry, or not our carry, our current node, all the way to the, this is why we use the dummy node. So we're going to move our current node all the way to the next of the dummy, right? So we're going to move it over here. So we're going to have our current node here. Then we are going to break this little chain, because for our reverse list, we don't need to include the dummy node. And now we're simply going to reverse this, right? So we're just going to reverse this 7087 list, and that's going to give us a reverse list. So that will give us 780.7. Not really sure why this is doing this, but I'll figure that out later. But anyway, so we're going to have this list, and that's what we're going to be returning, and this is going to be the new head of the list here. So that's what we're going to be returning. So that's the final step, is once you actually do get this whole 7807, you have to do a reverse. And there is one more thing, right? There's one more thing. Let's say you added some numbers. Like, let's say here, this was like a 7. And we added these numbers, right? And then these both become out of bounds, and then this becomes whatever. But now we actually have a carry out bit, right? So we do have to check, once we're actually done adding these two lists, if we have a carry out bit, we actually need to put a 1 in the front of like the new list that we made before reversing, obviously. So it would actually go like over here. So that's going to be like our condition. Like if we do have a carry out bit, because we added the last 2, even though both of these are out of bounds now, we actually need to add a 1. And so that's going to be the final thing. So let's review our steps. So 1 is going to be reverse the lists, right? And then 2 is going to be sum up the lists, and then 3 is going to be reverse the result. Okay, and like I said, we're going to use a helper function to reverse lists because we're going to do multiple results, so we might as well. So it's pretty straightforward, as long as you kind of understand how a carry in bit works and a carry out bit, and that you have to know that when you add, you have to actually add both of these and the carry bit. So essentially, in a normal, like low division addition, it would be something like, you know, 1, like if you had 2 numbers, you would add like A plus B plus C in would be your carry in, and then you would get your total, and you would get your C out. And then you'd use your C out to be the C in of the next thing, which is kind of what we're doing here. This is the carry in and the carry out. Okay, so let's actually code it up. We have enough now. So first, let's make a reverse list function. So it's pretty straightforward, right? So we need to make a def reverse function. It's going to take the head of a list. We're always guaranteed to have a list here too. So these lists are 1 length. So we're never given like an empty list. So we're going to have a previous standard reverse list problem. We're going to have a cur equals the head. And we can just say while cur, and this is what I showed earlier. So we're going to make a temp for cur next, because we are going to take cur next and make it to point to previous. So we need to save the cur next. So that's going to be over here. Then we're going to say previous equals cur, and cur equals temp to move that up. And then when, so we actually have some formatting issues here. So let's fix those. Okay. I think we should be good now. Okay. So and then finally we return previous, because remember our head is out of bounds here, and our previous is actually the new head of the list. Okay. So now we need to reverse these 2 lists. So let's do that. So let's just say L1 equals reverse of L1, L2 equals reverse L2, and now we're going to make a dummy node. It's not going to point to anything. We're going to make a cur. It's going to equal to the dummy node. We're going to make a carry bit. It's going to be 0, and then finally now we need to do our loop for the addition. So while L1 or L2, while either one of these has a value, let's get these values. So we could say like L1 val equals L1 val if L1 equals none, else 0, right? So if our L1 is out of bounds, we can just make it 0, because we're not going to be able to get the value, right? Like let's say our list 1 is only 2 nodes, and our list 2 is like 7 nodes. We're going to be out of bounds here for a long time. So we're just going to say, let's get the value if we can, but if it's out of bounds, if it's none, null, let's make it 0. Same thing for L2 val. So if it does exist, let's get it. Otherwise, let's just default to 0. Okay, and now we need to actually move both of these L1 and L2 because we just took them. So we need to move the pointers to the next node if we can. But if they're already null, then let's just leave them the way they are. So we can say L1 equals L1.next if L1 does not equal none, else L1, right? So if L1's already null, let's just do nothing. Let's just leave it the way it is. Same thing for L2, L2.next if L2 does not equal none, else L2. And this is just going to be a little bit cleaner because we can just do all our logic in one while loop instead of like having to check if we do have something left in the end. So you can definitely make this like take more lines of code if you wanted to. Okay, so now let's get our total. So our total is going to be the L1 val plus L2 val plus the carry in bit, right? And then we're going to divide that by, we're going to mod it by 10. That's going to be, the total is like the number we're actually putting in. It's going to be all this added together, modded by 10. Because let's say we get 17, we just want the 7. And now finally we do the carry, and it's going to be similar. So the carry is going to be all the same code, except instead of mod 10, it's going to be divide by 10, right? So if we get a 17, our carry should be a 1. So 17 divided by 10 is 1, because it's integer divide. So it's going to drop the remainder. Okay. Now finally we do cur.next. So our current starts with the dummy node equals, we need to make a new node with the total that we just got. And then we need to move our current over. Okay, so now once we're out of this loop, both L1 and L2 are pointing to null. But remember, we do have to check that final carry out bit, because if that carry out bit is a 1, we need to actually address that. So let's do that. So we can say if carry, we can address that, right? So cur.next equals list node 1. Okay, so we can do that. Now we need to do a couple more things, so let's just get some more space here. So now our list is actually looks like this, right? So it's going to look like the dummy node with these nodes in reverse order, but we actually need to reverse them. So we were going to make our current over here. We're going to make it over here, so get rid of that. It's a little laggy. Okay, we're going to make it over here, and then we're going to reverse this list. And we're going to sever this connection because we don't want the dummy node inner outcome. Okay, so let's do that. So we can just say over here, cur equals dummy.next, and dummy.next equals none. That's why we use the dummy, so we knew where the head of the list is going to be. That's why the dummy is really useful. Now we can finally return a reverse of cur. That's going to be the reverse list, right? So essentially our list is going to look like this. We're going to reverse it, and then the new head of the list will be over here, and that's what it will return. So we can just return reverse of cur, and finally, let's take a look to see if it works. Okay, it looks like it does. Okay, and it's reasonably efficient. So let's look at the time and space complexity here. Usually time and space for linked lists is almost always O of n, but let's take a look. So we are reversing L1 and we are reversing L2. So we have to traverse them both. Right, so because we have to traverse them both, that's going to be like, let's say L1 is n, and then L2 is maybe like m or something, or m and n, whatever it is. So that's already going to be, you know, big O of m plus n, essentially. Whatever, if m is the length of list 1 and n is the length of list 2, because we're traversing both of them, we're reversing them. Okay, now we make this dummy, doesn't cost us anything. Now we traverse these lists. And so this part is actually going to be O of whatever's greater, L1 or L2. So it's going to be the max of L1 or L2. But that's going to be less than this value here. So we can ignore this. And then we can ignore this carry. And then finally, for our reverse, that's also going to be the max of L1 and L2, which is smaller than this. So that's going to be our time complexity here. Now what about our space? So what are we doing? So we are actually reversing these in place. So that costs us nothing. And then what else are we doing? So we do create a new list, right? We do create a new list. And then our new list is going to be length, like I said, it's going to be max of m or n, essentially. That's going to be our space complexity here. So space time. So for example, you know, if this is 4 nodes and this is 3 nodes, then our list would be 4 nodes, maximum 5 nodes if we do have a carry, but that's going to be negligible. It's going to be the max one of these, you know, maybe plus a node, but it's plus 1 is negligible for big notation. So that's going to be that. It's just going to be the maximum one of the lists because we are reversing these 2 lists in place. If you were to make 2 new lists, then it would be m plus n as well because you're making 2 new lists. But because we're not, we're just doing max m plus n, and for the time it's m plus n. All right, so that's going to be it for this problem. Hopefully I explained it pretty well, and it's definitely a good one to know, definitely a good one to practice linked list problems. And these linked list additions, or just like these kinds of additions where you need to either add node by node of a linked list or an array, are really common. So I would encourage you to get familiar with how addition works with a carry bit, and just like practice that. Make sure you get it right. Make sure you handle the edge cases where you do have a carry out, even though you're out of bounds on your list and things like that. But that's going to be it. If you like this video, then please leave a like and subscribe to the channel, and I will see you in the next video. Thanks for watching.